Hello everyone, welcome to this next session on programming for analytics and introductory programming on R. Today is the session 7 of R programming, and today we are going to deal with matrix in R. Now before I actually start this session, generally it has been a practice that I always tell you certain interesting facts about R, and today's interesting fact is, where do we use R? R is having a wide spectrum of usage today. So you're using R in finance, you're using R in banking. You can also use R in healthcare, social media and e-commerce. So there's quite a bit of domains or specializations where we can use R. Now, having understood the fact, let's get into the R studio and see how we can create matrix in R and how we can work on various matrix operations in R. So without wasting much time, let's get into the R studio now. Okay, now I am in the R studio. The first and the foremost thing is, if you want to create a matrix in R, you require a function, and the name of the function is matrix. So how do you create this particular matrix in R? The option is very simple. You need to use a function called as a matrix function. So first let's try and understand how this matrix function works. So in order to get a help on this particular matrix function, I will make use of the help function and pass this matrix as an argument. So let's see how to do that. So I'll say help, and I'm going to use matrix, and I'm going to run this line of code. So now you can see that you are getting the help on the matrix function. So you can see that matrix basically has got data. So every matrix will have a data. Then it will have the number of rows, it will have the number of columns, and there are certain other parameters like by rows and dimension names and all those stuff. So we shall see how to work on a simple matrix now. Remember, a matrix is a collection of elements which are homogeneous in nature. So you should not forget that. So we shall see how to create this matrix, and the elements of the matrix are always arranged in rows and columns. So let's create a simple matrix now. So what I'm going to do is, I'm going to call this matrix as matrix A. So let me call it as mat A. Mat A basically means matrix A. So I'm going to make use of the matrix method here. So I'm going to give the data. Now I'm going to give the elements of the matrix. Now data basically means elements of the matrix. So I'm going to use the combine function and give 9 elements to this particular matrix. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Great. So now I have given 9 elements to this particular matrix. Now this 9 elements has to be arranged in the form of rows and columns. Now how do I specify the number of rows and number of columns? Pretty simple. So you have an option called ncall. Ncall will give me number of columns. So I am going to specify number of columns is equal to 3. And I am also going to specify number of rows is equal to 3, and I am going to actually end this particular function as of now. So let me run this particular line of code. So you can see that a matrix has been created. Now if I want to actually show this matrix, I want to print this matrix. So I can print this mat A. When I print this particular mat A, now you can see that the matrix is appearing on your output window. So you can see that you have 1, 2 and 3. These are the number of columns, and 1, 2 and 3. These are the number of rows. So this matrix is of the dimension 3 cross 3, which means there are 3 rows and 3 columns. So totally there are 9 elements in this particular matrix. So this is the basic idea of how to create a matrix in R. But now you also need to understand how these elements are arranged. See, I have given the elements as 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements I have given. So when the matrix is formulated, see that the elements are arranged column wise. So you have 1, 2, 3 in the first column. I have 4, 5, 6 in the second column, and I have 7, 8, 9 in the third column. So now what I want to do, I want to arrange these elements by rows. So I don't want the arrangement in columns, I want to arrange by rows. So how do I do that? I have to make a small modification here. So what I am going to do is I will say by row is equal to true. So when I say by row is equal to true, what does it mean? I am going to arrange the elements row wise. So let me rerun this line of code and let me print the matrix now. Now you can see the difference between these two matrices. The first matrix, you can see the elements are arranged as per column, and in the second matrix the elements are arranged as per rows. So you have to identify what kind of output you want. If you want the elements to be organized in the form of rows, then you have to initialize by row is equal to true. If you don't specify anything, then the elements will be arranged in terms of columns. So now you understood how to create a matrix in R. Now you can also create a matrix using a vector. That is very important. Now you know what a vector is. A vector can have an atomic value, or a vector can have a multiple number of values. So in order to create a matrix out of a vector, you need to have vector with multiple values. So first you have to create a vector with multiple values and pass that vector as an argument to this particular matrix. So let's see how to do that. Now what I am going to do is I am going to create one vector called v1. Now this particular vector v1 will have some values. So what I'll do, I'll give some values 10, 20, 30, 40, 50, 60, 70, 80 and 90. So I've given 9 values. I've given 9 values to this particular vector, numbers ranging from 10 to 90. Okay. Now what I'm going to do, I'm going to create a matrix out of this particular vector. So I'm going to call this matrix as mat_b. So that's the name of the matrix. So I'm going to start my matrix function now. So my matrix function is started. Now what I'm going to do, I have to supply the data to the matrix function. Now this data is actually available in this particular vector. So I will pass v1. So v1 is the name of a vector which has got values 10, 20, 30 till 90. Then I'm going to specify the number of rows. So I'll say number of rows is equal to 3. Then I'm going to specify number of columns is equal to 3. So I'm specifying 3 rows and 3 columns. Then I am going to actually also specify, say, by row. So that means you are going to arrange the total matrix in terms of row. So by row is equal to true. So let me actually execute this line of code. So your matrix is created. But before creating the matrix, it is giving me an error. The error is it says v1 not found. The reason is we have not executed this vector. That's all. So what we have to do is first we have to execute this vector which is available in line number 8. So it's executed now. Now we will execute the matrix function. So you can see that the matrix is created now. Now what I'll do is I'll say print matrix B. So now when I say print matrix B, now you can see that the matrix has been created. So like this, either you can pass the data directly into the matrix, or you can create a vector and then pass that particular vector into the matrix. Okay, now we have seen how to create matrix in different types. Now we'll show you one more type where I'm going to create a matrix using a sequence. So we have used sequence in the list before. I'm going to make use of the same sequence here where I'm going to create a sequence in a matrix for data. So let's see how to do that. So I'm going to create a matrix called, say, mat_c. So that is the name of my matrix. So I have a matrix function. Now in this matrix function, I'll say C of 1:9. So it is basically a sequence. So in this, I'm going to specify the number of rows is equal to 3 and the number of columns is equal to 3. So you can specify by rows if you want. Then I'm going to print the matrix C, print MAT and C. That's my matrix object. So let me run this line number 12 and let me also run this line number 13. So you can see that the matrix is created. So there are 3 ways where you can create. One is you can keep the data directly inside the matrix function, or you can create a vector and pass that vector into the matrix function, or you can make use of a sequence in place of a data to create a matrix in the matrix function. So this is how you can basically create matrices in R. Okay, now having understood this, there's one more parameter in the matrix function which is called as dimension names. So we need to understand what is this dimension names. See, when you look at this output here, you can see that the column names have been numbered as 1, 2, 3 and the row names have been numbered as 1, 2 and 3. So sometimes I would want that particular matrix to have different column names and different row names. It's something like, giving heading to that particular matrix. So dimension names will basically help me to actually give names for rows and names for columns. Now how do we do this? I'm going to illustrate this with an example. Okay, let's create the same matrix what we have taken in our earlier example, matrix C. So I'll just copy this particular statement here and I'm going to put it down here. Now I'm going to make this as matrix D. So this matrix D will have numbers from 1 to 9. So what I'm going to do is I'm going to put now dimension names. So I want to put this parameter called dimension names. So I told you that this dimension name will be in the form of a list. So what I'm going to do is I'm going to create one list. So in this list, I'm going to give the column names as column 1, column 2 and column 3. And I'm going to give the row names as row 1, row 2 and row 3. Let's do something like this. I'll give the column names as A, B and C and I'll give the row names as 1, 2 and 3. So how do I give A, B and C? So I'm giving the column names as A, that is my first column, then B, that is my second column, and C, that's my third column. So my first column names are given. Now what I'm going to do, I'm going to choose the row names here. So row names also I'm going to give it as say 1, that's my first row, then 2, that's my second row, and 3, that's my third row. So that means now you have created dimension names. That means you are giving the names of rows and columns. And remember, dimension names will always accept the data in the form of a list. So that is why we have used the list function there. So let's see if this particular piece of code runs. So first let me run this piece of code. So it is actually expecting an unexpected symbol. So I think somewhere we have made some error. So let's figure out what that particular error is and we will rectify this particular line of code. Okay, we got to know what the error is. I think here we have actually put a period instead of comma. So it is 2, 3. So I think that's the error. So let's rerun this line of code. Perfect, it's working perfect now. So let me run this matrix and let me print this matrix now. So I'm printing the matrix. So now you can see that the column names are appearing as 1, 2 and 3 and the row names are appearing as A, B and C. So that's how you basically use dimension names in order to give the column headings and the row names to this particular matrix. Okay, great. So now one more important thing is how do you access the elements of the matrix? That is also very important. See, once I create a matrix, I need to access the elements. So how do I access that particular elements? So let me clear off all this dirt on my console. So let me run this particular matrix once again. So now I have this matrix. Now I want to access a particular element. So if I want to access a particular element, so I have to specify the column and the row intersection. So how do I do that? So what I can do is I can say print, then I can say the name of the matrix, matrix D, then I'm going to give the subscript. So in the subscript, I want to specify that I want the first column and the first row. So here 1, 1 means I want the first column and the first row. So when I run this, you are getting the output as 1. So because 1 is the element which is found in the intersection of the first column and the first row. Suppose if I want all the columns in a particular matrix. So what I can do, I can say print mat D. So here what I can do, so here in this case I don't specify anything in the row, I just put a comma here and I put 1. So what does it mean? It means that it prints all the rows it prints all the rows of this particular column 1. So when I run this, so you can see that you are getting 1, 2 and 3. So that means of column 1 it is printing all the rows. So like this you can basically control things. So suppose if I say print mat D, so I'll give 1 and comma. If I give 1 and comma, when I run this particular line of code, you are getting 1, 4 and 7. So that means you are actually printing the first row. And when I put comma here, which means you are printing all the columns. So when I say 1 comma nothing, that means you are considering it all the columns of the row 1. So that is how you access the elements of this particular matrix. Now one more interesting aspect of a matrix is you can perform arithmetic operations on a particular matrix. Suppose if I want to add two matrices, I can perform arithmetic operations on that matrix. Let's see how to perform a simple arithmetic operations of two matrix, that is addition of two matrix. So let's take an example now. I'm going to create a matrix called say A. A is the name of the matrix. So this matrix will have say 9 elements. So I'm going to create a matrix of 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I'm going to specify the number of rows is equal to 3 and number of columns is equal to 3. So this is a matrix of 9 elements. So let me print that particular matrix. Okay, so then what I'm going to do, I'm going to create another matrix called B. So this matrix function will basically take another 9 elements. So what I will do here is, so I will call these elements as 11, 12, 13, 14, 15, 16, 17, 18 and 19. Okay, now here I have number of rows is equal to 3 and I have number of columns equals to 3. So now I have created two matrices. One is matrix A and matrix B. So let me print the value of matrix B also. How does it look like? So let me clear off this particular screen. So I am running this function. So my matrix A is created. My matrix A is printed. So I am creating another matrix called B and I am printing the matrix called B. So now you have got two matrices. One is A and B. So I want to add these two matrices and store it in C. That means I want to add the contents of matrix A with the contents of matrix B. So I can do a simple arithmetic operation here. I can use one matrix called result. Result is equal to, I can say matrix A. So it's not matrix A, I'm sorry. It is A is one matrix and B is another matrix. So when I say result is equal to A plus B, and when I print the value of result, you are going to get the resultant matrix, that is the added matrix of A and B. So now let me run this result is equal to A and B. Now I print the value of result. Now you can see that the matrix is getting added. So you can see that 1 plus 11 is 12. Then you can see that 4 plus 14 is 18. 7 plus 17 is 24. So you can see that the relevant elements of matrix of A and B have been added and the result is stored in another matrix called as result. So this is how you perform arithmetic operations on a particular matrix. Okay, in this session you have learned how to create a matrix using data, how to create a matrix using vector, how to arrange the matrix in terms of rows and columns, how to give dimension names to matrix, and you have also seen how to access the elements of the matrix, and we have also seen how to perform some arithmetic operations on matrix. Thank you so much for watching this particular session. I will see you in my next session where I am going to teach you another concept on programming in analytics. Till then, take care. Bye-bye.